Welcome to my channel. This is Prompt Engineer, and today in this video, we are going to look at Langchain. It's an amazing framework to get started in building apps, and I am having so much fun creating apps for myself and for my friends. And I'm thinking of creating web apps and even exporting my services and selling my services to other companies. So let's get started. This is a pretty good framework uh, that has been created, recently. So I've created a Google Colab, and I've included a few snippets of examples and explanations. If you like to follow through along with me, you can have a click. You can just click on the link given in the description, and then we can get started together. So, Langchain. What is Langchain? Now, Langchain is basically a framework for developing applications powered by language models. Now, you have heard of ChatGPT, GPT-4. So, after the large language models, have developed, Langchain came into picture because it provides so much integration with the language models. You want to create an app, you could create an app even before Langchain, but now what you can do is you can integrate the app or give the app the power of the ChatGPT, for example, large language models. Now, Langchain is data aware, means it can connect a language model to other sources of data. For example, you have a PDF, you want to ask questions to the PDF, and you want to ask smart questions to the PDF that is not available in the PDF, for example. Then what your model can do is that it can fetch. There are agents, and that you can call upon agents to fetch you the smart answer. An answer which is not available in your PDF. So Langchain provides you the framework to read the PDF, read your email, go into your Twitter account, and do all sorts of things that you will see in the later part of the my videos. But in today's video, we're going to look at the nuts and bolts of Langchain. Now, Langchain is agentic, which means it allows a language model to interact with its environment. It's not just a standalone system which is there, but it allows the large language models to interact with the environment. That's pretty amazing. Now, in terms of value proposition, Langchain frameworks provides two things. First is the components. There are 6 components. If you consider the schema, there is 7 components, but the Langchain provides modular abstractions for the components necessary to work with the large language models. Now, Langchain also has collections of implementation for all these abstractions. They're very easy to use, as we will see in the later part of this video. Use case specific chains. Now, chains can be thought of as assembling these components in a particular way. Now, you can create a lengthy chains, but you don't need to, you can even specify Langchain to call upon agents and choose which chains to, or choose the components of the chains that are required, basically. So basically, you have performed one action, and the output of that action goes as an input of the other action. So in this way, you can form chains, as we will see in the later part of this video. And now we have this Langchain sitting at the center, and we have these 6 modules that we are going to look into. The first one is prompts, then we have chains, we have indexes, we have models, we have agents, we have memory. Pretty simple, but very important if you want to create these sort of apps that you've been always looking to create for yourself. Now, to get started, we need a few libraries. So these are the libraries: pip install, Langchain, OpenAI, TikToken, Cython, unstructured, PDF miner. This is a Facebook given library. So FAISS. I'm using CPU version because I have a CPU, and Google search results. I'm going to run this and get everything installed here. So as you can see, this is getting installed. So let's wait for some time. Let's wait for it to install, and let's move to the next section. Now here we are going to import the OS. So import OS, and we are going to basically work with OpenAI because that's the AI or large language models, that has revolutionized the natural language. So natural language processing. So we are going to use ChatGPT or OpenAI in this case. Now import OS and os.environment, and we store the value of our API key of OpenAI in the OpenAI API key. So how to get this key, you need to go to platform.openai.com, and then you go to API keys. You create a new secret key. Create secret key. Just copy this and paste it in this location. So you're done. So you have seen this successfully being completed. So all our installations are done. I'm just going to close this. Now we can run this import statement. That's done. Now we are ready to learn all these modules. The first one is models. So there are three types of models. The first one is LLMs, which is large language models. Now model is anything that provides a text out when you give a text in. So Langchain provides a generic interface for large language models. These are the core component of Langchain, because without large language models, it is pretty useless. The Langchain is pretty useless. Now, Langchain is not a provider of LLMs, but it rather provides an interface to interact with the variety of LLMs. Now, I have given links to the list of LLMs here. You can just click and you can see there are different kinds of different companies which provide the LLM services. The favorite one is OpenAI. We have Cohere, Banana, GPT for All, Hugging Face is another famous. We have Runhouse, we have Stochastic AI, Writer. There's too many to perform. So, here's the pro tip: if you face token restrictions in any of the LLMs, you can just try the other one. The framework is pretty simple, and it's pretty easy to integrate. So you don't need to buy any service or LLMs. Now let's run this code. So this is the import statement from langchain.llms. We import the OpenAI. We get an instance or start an instance of OpenAI and store it in this variable. Now this variable has all the power of OpenAI, module. So we're just going to ask the LLM, tell me a joke on hens. So I'm just going to run this. So what did the chicken say when it saw a bird of prey? Run for the coop. So let's move on then. So this is the LLMs. It's just the OpenAI. Now, chat models. What are chat models? Chat models are the variations on language models, while chat models use language models under the hood. Basically, chat model is nothing without the language models, but the interface is a little bit different. It's not as simple as text in and text out, because when we want to create a chat model or want to use a chat model, for example, you want to create a chat bot, you need uh, sort of memories to be integrated in them. You don't want your chat model to forget what conversations you had just a moment back. So this is the memory that's integrated in the chat model, and under the hood, it is basically a language model. It is smart. It has the large language models, but it has memories also. Now, the list of chat models that are available for the integration are Anthropic, Azure, OpenAI. I'm going to use OpenAI as an example. I'm going to close all this. Now, this is an example from langchain.chatmodels. We're going to import chat OpenAI. And from Langchain's schema, we're going to import AI message, human message, and system message. Now, as I was saying, schema can be thought of as another components, because, for example, in the schema, we have three things that we can use. The AI message, which is the message given out by the AI. Human message, which can be considered as a message that will be given by the user. System message, it is basically the brain of the AI. For example, in a system message, if you write a system message for the AI in the form of, for example, that you are, for example, I already have an example here, so I'm going to show you that. But before that, let's run this. So we start an instance of chat OpenAI with a temperature of 1. Yeah, 1, when you say it's the creative, the AI is very, very creative. When you say temperature is 1. Now, a temperature of 0, there will be no creativity. Now, pro tip, if you are going to use chat bots, for example, to take orders for a restaurant, you don't want your temperature to be 1, but instead you want your temperature to be 0, because we don't want any variability in the, we don't want any new things to happen. We don't want any abrupt things and any imaginary things to happen. We want it to be very predictable, so we keep temperature equal to 0 when we create chatbots for taking in an order for a restaurant. Now we initiate the instance chat, then we give the input of human message. Invert the meaning of the sentence. I love programming, so just going to run this. Content, this is an AI message because we give a human message, and the chat is an instance of chat OpenAI. So the output that it gave is, I hate programming, So that is the opposite or invert the meaning of the sentence. Now, another example that I have for you is if I give a message in this form, in the form of a list. System message is that you are a root assistant that mocks any questions asked for. So there's a brain of the AI. So you have just programmed the brain of the AI. And then the human message, invert the meaning of this sentence. I love programming, and chat of messages. We just print it. So we see the AI message that has been given out. It's, oh wow, what a trivial and unoriginal question. Fine, I suppose I'll indulge you. The inverted meaning of I love programming would be I hate programming. Happy now? So it's just a very rude assistant that you have programmed, the for yourself. So the system message is used to interact with the brain and the mind and the soul of the assistant. And the human message is what we pass as input, and the AI message is the output that we get. So these are the two models that you've talked about. The last one is embeddings. Now, text embeddings. It is a class designed for interfacing with embeddings. Now, there are a lot of embedding providers, for example, OpenAI, Cohere, Hugging Face. This class is designed to provide a standard interface for all of them. Now, embeddings create a vector space representation in a piece of a piece of text. This is useful because if you think about text in the vector space and you do things like semantic search or look for similarities, that is easier in the vector space. So in the text embedding converts your text into numbers. So list of text embeddings are given here. These are the different embeddings that you can use. We are going to use the OpenAI embeddings. Now, how to use the code? An example from langchain.embeddings.openai, we import the OpenAI embeddings, and we are going to create an instance of OpenAI embeddings. Text, this is a test statement. Query result, we're going to use embeddings.embed query, and we're going to put in the text. Let's print out the query result. So as you can see, this query result, which is the embedding of the text, it has been converted to numbers, and the length of the embedding is 1536. So this 5 word statement has been converted into 1536 floating numbers. So this is the use of embeddings. We cannot particularly see the embeddings, but it is very useful for the computer to work with. Now, the first is complete, that is the models, and the next we are going to look is prompts. So prompts are the preferred method of programming models right now. Now, where the input to the model is constructed from multiple components rather than being hard-coded. Now, the construction of this input is done through so-called prompt templates, which you're going to look. Now, to simplify the process of constructing and using prompts, Langchain offers various classes and functions. So let's look at prompts. This is just a simple prompt. We have already seen this. From langchain.llms, import OpenAI, create an instance of OpenAI. This is the prompt. So in the chatgpt, whatever you give, whatever input the user gives, that is the prompt. The human message is the prompt. So I'm just gonna run this. So we get write me a one-liner joke. Why did the fish say? What did the fish say when it hit the wall? Damn, that's good. Now let's look at prompt templates. Now, by using the template, it is possible to incorporate various variables into the models. For example, from Langchain, we import the prompt template. We get an instance of OpenAI here. Now, this is a template I've created. Within 3 quotes, I've given, I want you to act as a naming consultant for new companies. What is a good name for a company that makes, and within the curly brackets, we put in product. Then we construct a prompt template variable. We use this class. Input variables, we have one input variable, which is product, and we are going to use this template. So how to use this? So prompt equal to prompt template dot format, product is equal to colorful socks. So what this piece of code will do is that it will take the input of our input, which is the colorful socks, and put it in here, the input variables, and then put it in the template itself. So what is a good name for a company that makes colorful socks will be the answer. So let's print this out. Now, the final prompt is, I want you to act as a naming consultant for new companies. What is a good name for a company that makes colorful socks? So this is the final prompt that is being used by the AI. And the output of the large language models, because we have used LLM of prompt, and prompt, this is the final prompt. So the LLM gives the output of cheerful toes. Pretty good. So this is how you use template. You can use multiple variables here. Of course, you have to define it here, the input variables. Next is the example selectors. Now, it is so smart that if you give some examples, it can learn from these examples and give you the output as per the examples. So one of the examples is the max marginal relevance example selector. It selects examples based on a combination of which examples are most similar to the inputs, while also optimizing for diversity. It does this by finding the examples with the embeddings. Now, embedding again, that's a transformation of the text to numbers. Now, the embeddings are very useful. They can be used very easily by the computers that have the greatest cosine similarity. So the similarity is the cosine similarity, and it has been found out for the embeddings, and then iteratively adding them when penalizing them for closeness to already selected examples. So this is an example. So from Langchain.prompts.example selector, we import the max marginal relevance example selector. From the vector stores, we import the FAISS. From embeddings, we import the OpenAI embeddings. From prompts, we import a few shot prompt template and prompt template. So example prompt is this. So prompt template input variables is input and output, and template will be input is here and output is here. So these are the examples that we have provided. So when input is happy, the opposite is sad. Tall, short, energetic, lethargic, sunny, gloomy, windy, calm. So I'm going to run this. So these are the examples from which the AI should learn. Let's see. So example selector. So max marginal relevance example selector. From examples, we gave the list of the examples to select from, and the embedding class, we give the vector store that is used to store the embeddings and do a similarity search over. And this is the number of examples to produce, k equal to 2. So this is the main prompt, where mmr prompt variable is equal to few shot prompt template, and example selector is the example selector here. Example prompt is the prompt here. So prefix is give the antonym of every input. The suffix will be input of adjective, and output will be the input variable of adjective. So we're just going to run this. Done. Now we're just going to print. Final prompt is mmr dot format adjective depressed. So we want the opposite of depressed. So let's print it. Now here's the final prompt. The final prompt will have, the final prompt will have this. Give the antonyms of every input. Input is sad, input is happy, output is sad. Input is energetic, output is lethargic. So input is depressed, what will be the output? Now I'm just going to run it again. So the output is elated. So when the input is depressed, output is elated. Now there are two examples that has been outputted here. Now if you change this number of examples to produce to 3, and then you run it, then you see that you have now 3 examples to select from. So this is an example of the example selectors. Here it's very easy. If you just give a few examples, the AI will learn from these examples and give you the answer in your required template or style. Now output parsers. Now, this is just to get more structured informations. Now output parsers are responsible for instructing the model how output should be formatted and parsing output into the desired formatting. So I've given an example of comma separated list output parser. I just import it. Just import the prompts here. Import the OpenAI and the chat OpenAI. So I'm going to run this. Parse the output. Format instructions is output parser.get format instructions, and this is the prompt. The template is this: list 5 subjects. Input variable is subject, and format instruction is partial variable is format instruction is the format instructions. Just going to run this. We're going to use the AI model, temperature of 0. We don't want any creativity. Now input subject is your ice cream flavors. Just going to run this once again. So this is ice cream flavors. So these are the 5 ice cream flavors. So these are the 5 ice cream flavors. Okay, so this is just to structure the output. The next component is indexes. Indexes are used to structure a document. You use them in the large language models. Now indexes has 4 components. Document loaders. They are used to load the documents from various sources. For example, your PDF, your Word file, Twitter, email, and so on and so forth. Text splitters are classes responsible for splitting those uploaded documents into smaller chunks, because it is difficult for the computer to work with a large document as a whole. It's very essential that you break the document into different chunks, because there are token restrictions as well. So that provides a very easy way to work around. Vector stores. These are the database to store the vectors. and retrievers. These are the interface for fetching the stored vector store or stored databases, or the vector store, retrieve the information from the vector store to combine with large language models. Now, document loaders are classes responsible for loading. So list of document loaders are given here. I don't think I forgot to put the link here, but I'll just put the link when I send this out. Now, how to use this? From Langchain.document loaders, we import the unstructured Word document loader, and we are going to put it in a Word document. So I'm just going to here, and I'm going to go to this location. Just put two files here, open, and okay. So just going to load this. Load it, done, close. So from Langchain document loader, we load the example word, and we just print the length of the data. Let's print it out, and we print the data itself. Excuse me. So the length of the data is just 1, and the data is, all these text in this document has been stored as 1, just 1 document. So it's very difficult for the model to work with these large number of words. So we are going to use text splitters. Now, this text splitters are classes responsible for splitting the text. Now, this is a long document we can split up. So with open birds.txt, so I put a document of bird.txt as F. We read this text file, and we just, let's see the text file. So this is this text file that I've used. Now, from Langchain splitters, import recursive character text splitter. Here the chunks size is 50 and chunk overlap is 20. So now if we print it, we can see that it has been divided into smaller and smaller chunks. Now for the text of 0, the first chunk is that ChatGPT is a beautiful, intelligent based. So it stores the first part of this. Now you can play around with the chunk size. For example, if you increase the chunk size, then you can see that this page content or this text of 0 is increased here. Okay. Next is the vector stores. The vector stores are databases to store vectors. Now, these are the list of vector stores that are available. From Langchain, vector stores are just a database to store the vector, the embeddings. Now, from Langchain, we import the OpenAI embeddings, text splitters, vector stores, FAISS, document loaders, text loaders, and then we are going to load this bird.txt again, and then you're going to split that. Then you're going to split the documents. Okay. We're going to use embeddings, OpenAI embeddings, and length of docs. So let's look at the length of docs. There are 9 docs because we have used 100 here. So for example, it's split into 50 chunks. Then we get 17 here, the length of docs. Now the embedding list, let's look at the embedding lists. So the embedding list, we have 10 embeddings, and these are the embeddings. So these are just numbers that we have already seen. Retrievers, these are used to retrieve the models. So from FAISS, we want to retrieve the model. So we import, we use this module from documents, text embeddings. We retrieve this and print the retriever. So this is kept in this location. Okay. The next component is memory. We of course need memory to store and retrieve data, especially when you are using the chat message. So from Langchain.memory, we import the chat message history, and then you're going to use history as chat message history. User message is hi, AI message is what's up. Then user says what's the capital of Japan. Then what output do you think the AI will give? If it doesn't have the memory inbuilt, it would say that I don't know anything. But here, if you use memory, then you can look at the messages that has gone till now, until now. So until now, the human message was hi, the AI responded with what's up. The human message is what is the capital of Japan. Now when you say chat history.messages, so this is the next output from the AI. So this you can programmatically you can add, as you get the inputs, you can create a chatbot for it. So in the next video, maybe I will create a chatbot for you using this wonderful feature of memory here. Now let's look at chains. Now, Langchain, the word itself says that there are chains. So chains, it allows us to chain multiple language models together and prompt templates together to create a more, complex and beautiful applications. Chains are wrappers that are in a series of single components. Now, using an LLM in isolation is fine for some simple applications, like ChatGPT, for example. You just want to ask a few questions. But if you want to integrate so many things, if you want to upload a document, if you want to read the document, search Wikipedia, so you're going to need chains. but many more complex ones. Okay, chains allows us to combine multiple components together into a single coherent application. For example, you can create a chain that takes in user input, format it with the prompt template, and then pass it in the formatted response to an LLM. So that is an example of a chain. Now, LLM chain is a simple chain that takes in a prompt template, formats into user input, and returns the response to an LLM. So this is an example of a prompt template. We've already seen this. Langchain.prompts import prompt template. From Langchain.llms import OpenAI. LLMs equal to OpenAI temperature 1. Prompt is prompt template. We give this input variable, and the template is this. What is a good name that makes product? Run this. From Langchain, we make another chain. So from Langchain, we import the LLMs. We use the instance of LLM chain. So this is the instance. How do you use that? So you can see rainbow, toes, socks. Okay. Now using in the chat models, how you're going to use. So this can be used in the chat model as well, where there are human message prompt like this, and the chat prompt template like this, and you can use in the same way, but with memory in case of the uh, chat style, because in chat models we have memory. In the sequential chain, this is a simple sequential chain where each step has a single input output, and the output of one step is the input to the next. So we're going to initialize this with a temperature of 1. Now this is the prompt. This is a chain that is created. We run this. We create a second prompt. Now second prompt, it creates a catchphrase for the following company. So the first creates a good name for the company that makes a product. The second creates a catchphrase for that company name. So you're going to combine these two using simple sequential chain, and inside the chains you can put chain 2. So the first chain is this, the second chain is chain 2, and then we are going to have this. So the name of the company that makes colorful socks is Sockbow, and the catchphrase for that is Sockbow, step into a world of comfort. So that is the change that we have talked about. Now the last one is agents. Agents are agents. They are very powerful in that they have been given different tools that they can use. Langchain allows us to set up agents powered by large language models that can use tools like Google Search, Wikipedia, Calculator, giving you unlimited power. Some applications will require not just a predetermined chain of calls to LLM other tools, but potentially an unknown chain that depends on the user input. In this type of chains, there is an agent that has access to a suite of tools. Now, depending on the user, the agents can decide which tools to use. That's very powerful. Now, the agent is what? The agent is the language model that drives the decision making. The list of agents are given here. So you can see the list of agents here. The list of tools, how language models interact with the tools, with other resources. So these are the tools that are available for the agents. For example, SERP API is a famous one. Wikipedia, we have Google Search, DuckDuckGo Search, Shell Tool, Bing Search, Apify. We have toolkits. When a set of tools are put in together, we have toolkits. So these are the toolkits: Python agent, natural language API, pandas data from agent. We have agent executors. So these are the executors, the logic for running the agents with tools. Okay, so you can read more about the agent executors, how they are done. Now, just gonna run this from Langchain agent. We load the tools, initialize the agent. We use the agent type OpenAPI. You're gonna run this. You can get this SERP API from the Google from going to that link, SERP API, and you can go here. You can just sign in using Google. For example, I have already signed in. We're going to go to API key, and then we're going to copy this and paste it here. So next we're going to load the tool. We're going to give the SERP API LLM initialized agent. So agent.run, who is the Leo DiCaprio's girlfriend? What is the current age? Raised to the power 0.43 power. Okay, so the agent is thinking, I need to find out who Leo DiCaprio's girlfriend is, and then calculate her age raised to the 0.43 power. Now the action that is decided is to search, and then the action input is Leo DiCaprio's girlfriend. So observation: he went on to date this beautiful girl, so many people, but before finally settling down with the current girlfriend, okay, who is 23 years a junior. So this agent is still running. It is still searching the Google for answers, and I hope it will give me the answer very soon. Now, this was a very fast course on understanding the 6 different components of Langchain. Now, if you like this video, please like the video, put a thumbs up, uh, comment what did you like on the video, share this video. And if you find this video and particularly this channel interesting, you can just consider to subscribe to this channel. It would be great if you do that. But I will come up with new case studies and new work use cases for Langchain, because I have been using so many tools, and it's just a work to get it into sort of a video for you. So we'll meet you in the next video. So see you then. Bye bye. Thank you. Thank you for listening to me for such a long time. I just don't want to go. I just want to chat with you. But I respect your time, and you can just try it out. The collab that I will attach in the link. And basically, I think that is it. That is the summary of Langchain. And I'll see you in the next video. Thank you.